program could handle different errors in, well, different ways, and still run that super important cleanup code every single time, no matter what? Well, that's exactly what we're diving into. You're going to learn how multiple catch blocks give you this incredible precision, and how the finally block makes sure your code is always tidy.
I mean, think about it, right? Getting an array index wrong is a completely different kind of mess than trying to divide by 0. If you handle them both the same way, you're missing a huge chance to make your code smarter and way more robust. So here's the game plan. We'll start with that one-size-fits-all problem we just talked about. Then we'll get into the cool tools Java gives us to fix it. We're going to see the magic of guaranteed cleanup, touch on those weird times when always isn't quite always, point out a super common trap you've got to avoid, and then pull it all together into a simple playbook for you. All right, first up, let's look at a super common way people catch errors and why it's not always the best idea. Okay, check out this code. Inside this try block, we've got 2 potential landmines, an array index out of bounds exception and an arithmetic exception. 2 totally different issues. But see how they both get caught by that one generic catch block? All we get is a vague "some error occurred" message, which isn't very helpful, is it? Yeah, so we know something broke, but we have no clue what it was. This is a total nightmare for debugging. And you can forget about handling each error with a specific fix. So let's see how we can do this way better. And this is where we bring out the precision tools. Let's talk about using multiple specific catch blocks. Now look at this. It's so much better. We've totally tailored our response. We have one catch block just for the array index problem and another one just for the division by 0 problem. Now we can give a specific, helpful message for each one. This right here is how you build code that's not just smarter, but also way easier to maintain. But hang on, that brings up a really good question. In that first block of code, we had 2 potential errors, one after the other. So which one actually gets handled? And here's the key thing to remember. The moment the code hits that R5, bam, it throws the array index out of bounds exception. The right catch block immediately kicks in to handle it, and then the rest of the try block gets completely skipped. That division by 0 code, it never even runs. The program just jumps straight to the end of the whole try-catch structure. This leads us to a golden rule. Order is everything. You absolutely have to list your catch blocks from the most specific to the most general. If you mess up and put that generic catch exception E first, it's like a giant net. It'll catch everything, and your more specific blocks will never, ever get a chance to run. Thankfully, the Java compiler is pretty smart and will call you out on this with a compilation error. Okay, handling specific errors, check. But what about that piece of code that you need to run no matter what? I'm talking about code that has to execute whether an exception happens or not. Well, for that, we've got the finally block. And this is its whole purpose. Just think of finally as your reliable cleanup crew. It's perfect for stuff like closing a file, shutting down a database connection, or releasing any other system resource. It makes sure you never leave a mess behind. So let's just walk through this. The code in the try block throws an arithmetic exception. Then the catch block jumps in and handles it, printing our error message. And then what happens? The finally block runs. It happens every single time. It's the guaranteed last step. But what about a return statement? Does that break the pattern? Nope. Even if you stick a return right inside the try block, Java is smart enough to say, hold on, I've got to run the finally block first. It executes that cleanup code before the method actually returns. It's an amazing guarantee. Now, I've been saying finally always runs, and that's like 99.9% true. But you know how programming is? There are always a few weird extreme edge cases where that always guarantee can actually be broken. Basically, if you do something drastic, like call system.exit to shut down the entire Java virtual machine, or if something truly catastrophic happens, like the JVM itself crashes or someone pulls the plug on the server, then yeah, the finally block might not get its chance to run. But in any normal day-to-day program flow, you can absolutely count on it. Okay, let's switch gears and talk about a really common and dangerous trap. I call it the return trap with finally blocks. Getting this one wrong can lead to some incredibly confusing bugs. Listen up, because this is super important. If you put a return statement inside a finally block, it will completely override any return that happened in the try or catch blocks. And what's even worse, it can silently swallow an exception that should have been thrown. Your program just moves on and you're left scratching your head wondering why things are so broken. And honestly, the experts all agree on this. As Baldung says, it's just bad practice. The job of the finally block is to clean up, not to control the flow of your program. Putting a return in there is just asking for trouble. Seriously, just don't do it. All right, let's wrap this all up and put it into a simple playbook that you can start using in your own code right away. Here it is, your go-to cheat sheet. Use multiple catch blocks when you have different kinds of errors and you need to handle them differently. That's for precision. And use a finally block when you've got that critical cleanup code, the stuff that has to run to make sure your app doesn't leave a mess. That's for guaranteed cleanup. And just one more pro tip for you. For anything involving resources, like files or network connections, modern Java has an even slicker way to handle this, called the try with resources statement. It automatically takes care of the cleanup for you, so you don't even need a finally block. It makes your code cleaner, safer, and is definitely something you should check out. So there you have it. You can now catch exceptions with pinpoint accuracy and clean up after yourself with absolute certainty. But what about creating and announcing your own exceptions? In the next explainer, we're going to tackle the difference between throw and throws. You ready to become a true master of exception flow? I'll see you there.